Welcome to solverfy.
Now to write down the decay for our iodine 131, we need to first look up appendix B to find out what is the mode of decay. And the appendix tells us that iodine 131 decays by beta decay. So it emits a beta minus particle. And then we have the anti-neutrino, and we have our unknown X. So we want to identify what's this unknown. We should be able to by just looking at the proton number and the nucleon number, so they must be conserved. So since the beta minus has a proton number of -1, X must have a proton number of 54, so that the total proton number is 53. Same thing with the nucleon number, it must be 131. So X, looking up the periodic table for an element with 54 protons, we should identify this as xenon. So it is xenon. So this is the decay equation. Now we are given an unknown amount, say activity or number of nuclide to be n0, and we want to find how long it will take for n0 to decay to 5%. 5% of its original value, so that is 0.05 times n0. We're going to use the decay law, that is the value n at any time after n0 is given as n0 times e exponential to the power of negative lambda t. T is the time, right, that we want to find. Lambda is the decay constant, which is given as ln 2 over t half, where t half we are given to be 8 days. So ln 2 over 8 days. What we need to do is we divide, or we cancel away n0 from both sides of the equation. Then we take the natural log of both sides. We should get negative lambda times t we bring the expression over to the left hand side to get our answer in terms of t. We should get a value of about 34.58 days, which is approximately 35 days. Now we are given another amount of iodine where the activity is 1 millicuries, or 1 times 10 power minus 3 curies. We want to find out what is the mass of iodine. To find the mass, we need to find what is the number of nuclides, and then we can find the mass. So the activity is defined as the decay constant multiplied by the number of nuclides. So we can get our number of nuclides by simply knowing the lambda. So from previous page, we already know that lambda is ln 2 over 8 days times n. But in this case, we need to convert the days to seconds, right? Since curies, we're going to convert later into decays per second. So what we have to do is multiplying 8 days by the number of seconds in a day. That's 24 times 3600. So this will give us in terms of seconds. Now we just need to convert our activity from curies to decays per second by multiplying by 3.7 times 10 power 10 decays per second per curie. So we can finally find what is our number of nuclides by bringing the entire expression over here, right, this expression, to the activity, right, divide it over. So we should get 1.0 times 3.7 times 10 to the power 7 divided by ln 2 multiplied by 8.0 times 24 times 3600. You should get a value of 3.69 times 10 to the power 30. So this is the number of nuclides, of iodine nuclides. To get the mass, we take the number of nuclides divided by Avogadro's constant, which is 6.022 times 10 to the power 23. This will give us the number of moles, and then we multiply by the molar mass, which is 0.131 kilograms per mole, to give us the mass in terms of kilograms. This will be 8.0 times 10 to the power 12 minus 12 kg. So with the particular activity 1 millicurie of iodine, we will need a mass of 8 times 10 to the power minus 12 kilograms of the iodine.